Hi, so in this video, I just want to give a little introduction about what we're going to cover in chapter 6, which is using the Laplace transform to solve differential equations. So this fits into maybe a broader method in mathematics where if we want to solve a problem, then one thing that we can do is transform it into an easier problem, solve that easier problem, and then use the solution to go back and obtain the solution of the original problem. So we've been doing this semester. So for example, if we wanted to solve a second order differential equation, we could set up the characteristic equation, which is just a quadratic equation, find the roots to that much simpler problem, and then use the information that we got from those roots to then tell us what the general solution is. So that's the idea that we're going to take here. It's just going to be, the algebra is going to be a little bit more complicated than solving a quadratic equation. So in this chapter, which is chapter 6, we're going to study the method of Laplace transforms, which again is one way that we can attack some of these differential equations. And let me just say that these methods of Laplace transform have applications throughout physics and engineering as well. So you may have already come across Laplace transforms, maybe in a different context. And so just to see where we're heading, we're going to apply this Laplace transforms to help us solve some differential equations. And so some of them are going to be things that we've already solved. So for example, this differential equation is second order linear differential equation with constant coefficients. So we could find the general solution, find the homogeneous solution, find the particular solution, and then plug in these initial conditions. And so we've done this before. It actually involves quite a bit of work to do that. So maybe using Laplace transforms, we'll get another method, and in some cases, this alternative method might be simpler than what we previously learned. In some cases, it might not be any better, or it might even be worse. So it's always good to have more than one method to solve a problem, and then think about which of these methods is going to be the most efficient way of solving a problem. But in addition to maybe finding some more efficient methods, we're going to also be able to solve differential equations that we haven't been able to solve before. So for example, down here, we have a second order linear differential equation as we did up here, except now the coefficients are not constants. And we haven't talked about how we can solve differential equations when the things multiplying the dependent variable or derivatives of the dependent variable are not constant. So Laplace transforms are going to give us a way to solve these differential equations, which up until now we can't solve. So in the other videos, I'm going to take you through some of the key ingredients of working with Laplace transforms.